Alright, so this is Theorem 4, where we are dealing with nth order homogeneous equations with linearly independent solutions. We are going to use this theorem to find particular solutions given initial conditions in Theorem 2. Theorem 4 states that if y sub 1, y sub 2, and so on, and y sub n are n linearly independent solutions of the homogeneous equation, the nth derivative of y plus p sub 1 of x, n minus 1th derivative of y, plus and so on, plus p sub n minus 1 of x, y prime plus p sub n of x, y equal to 0. And if capital Y is a solution of the homogeneous equation, then there exist numbers c1, c2, and so on, and c sub n such that capital Y of x is equal to c sub 1 y sub 1 of x plus c sub 2 y sub 2 of x plus and so on plus c sub n y sub n of x for all x on an open interval I. Alright, so that's theorem 4. So the next part, you don't have to write it down. Based on what we have gone over so far in this section, every solution of a homogeneous nth order differential equation is a linear combination y equals c sub 1 y sub 1 plus c sub 2 y sub 2 plus and so on c sub n y sub n of n linearly independent solutions. This is the general solution of a homogeneous nth order differential equation. Moving on to example 4, now we are going to be dealing with some initial values. Given a third order homogeneous linear equation, third derivative of y minus 6y double prime plus 11y prime minus 6y equaling 0 in 3 linearly independent solutions, y sub 1 equals e to the x, y sub 2 equals e to the 2x, and y sub 3 equal to e to the 3x, with initial conditions y of 0 equaling 0, y prime of 0 equaling 0, and y double prime of 0 equal to 3, find the particular solution. Alright. So, based on Theorem 4, this particular solution is going to come in the form y of x equal to c sub 1 e to the x plus c sub 2 e to the 2x plus c sub 3 e to the 3x. Now, because we are given the initial conditions, y of 0 equal to 0, and y prime of 0 equal to 0, and y double prime of 0 equal to 3, we're going to find y prime and y double prime. So y prime of x is equal to c sub 1 e to the x plus 2 c sub 2 e to the 2x plus 3 c sub 3 e to the 3x. Now for y double prime of x, c sub 1 e to the x plus 4 c sub 2 e to the 2x plus 9 c sub 3 e to the 3x. Alright, so now we have these three equations. We are going to plug in the initial values. So y of 0 should equal 0. 0 equal to c sub 1 e to the 0 plus c sub 2 e to the 2 times 0 plus c sub 3 e times 3 to the 0. For y prime of 0 equals 0, so 0 equals c sub 1 e to the 0 plus 2 c sub 2 e to the 2 times 0 plus 3c sub 3 e times 3 to the 0. Alright, for our last condition, for y double prime of 0 equals 3, so 3 equals c sub 1 e to the 0 plus 2c sub 2 e, oh, this should be a 4, so e to the 2 times 0 plus 9c sub 3 e to the 3 times 0. Alright, so let's simplify this down. First equation is going to be c sub 1 plus c sub 2 plus c sub 3 equal to 0. Second equation is going to be c sub 1 plus 2c sub 2 plus 3c sub 3 equal to 0. Alright. And for the final equation, the y double prime is going to be c sub 1 plus 4c sub 2 plus 9c sub 3 is equal to 3. Alright. So let's try to get one of these equations all in terms of c sub 3, or choose a variable. So I'm going to choose c sub 3. Alright, so for this top equation, c sub 1 is going to equal negative c sub 2 minus c sub 3. Let's see. Alright, so let's plug this into the second equation. We're going to get negative c sub 2 minus c sub 3 plus 2c sub 3 plus 3c sub 2, and which is going to equal 0. And now we are going to simplify this down. Oh, I messed up again. Sorry about that. It's going to be c sub 2 plus 2c sub 3 equal to 0. So c sub 2 is equal to negative 2c sub 3. So this is what we have so far. Now let's plug both of these in to this third equation. So negative c sub 2 minus c sub 3 plus 4 times negative 2c sub 3 plus 9c sub 3 should equal 3. Alright, now we also have c sub 2 right here. So it's going to be positive 2c sub 3 minus c sub 3 minus 8c sub 3 plus 9c sub 3 equal to 3. Alright, so let's simplify this down. C sub 3, negative c sub 3, 7c sub 3. It's going to be 2c sub 3 equal to 3. And divide the 2 over. And c sub 3 is going to come out as 3 over 2. Alright, so let's plug this back into here. C sub 2 is equal to negative 2, 3 over 2. Let me circle this. Alright, so c sub 2 is going to equal negative 3. Alright, c sub 1 is equal to 3 minus 3 over 2. So c sub 1 is equal to 3 over 2. Alright, so now that we've got all of our variables, Let's plug it back into the particular solution. So our desired particular solution is going to be y of x is equal to 3 over 2 e to the x minus 3 e to the 2x plus 3 over 2 e to the 3x. And that is our final answer.